All right. Let us also consider this question on the board here. We're having that two forces of 6 Newton and 8 Newton act at an angle 120 degrees on each other, with 8 Newton acting horizontally. Wow. Represent the vector using triangle and parallelogram, and find the resultant vector. Wow, wow, wow. All right, let's see how we can represent this vector using triangle and parallelogram. Now, we know that most of the time, as we try to draw the diagram, we may not be able to draw it to scale, but you have to make sure that your diagram is it actually reflects the question. Now, like when they are talking about 120 degree, it does not mean that you should just draw the triangle anyhow and just put 120 degree there. No, you need to actually measure the angle. All right. So even if you cannot measure it, maybe using a mathematical instrument, but you need to be a little bit. You need to predict. Okay. At least you already know that 120 degrees in the second quadrant. So knowing that alone should guide you. So if we are to represent this vector using the triangle, what we do here is for 1a, we have to use the triangle to represent. And remember what they said here, that the 8 Newton acts horizontally. So you already know the one that acts horizontally. So you have here, if we are starting here, AB, and this is the 8 Newton vector. And let's say this is, if you look at this from here to here would be 90 degree, and 90 plus 30 would be 120. So you can draw your diagram like this, and then this may be your P and your Q, which is 6 Newton. Okay, and you know that the resultant will be this other one. All right, this will be your resultant. So here you have 120 degree. Okay, so knowing how to represent your vector, okay, in a diagram like this is very, very important. Yeah, because it will really guide you. Yeah, it will guide you. So you have represented that that vector using you have represented those vectors using a triangle. So the next one is for us to represent it using parallelogram. Let's see how we go. So if you can represent using the triangle, it means that you will be able to represent using your parallelogram. So it will be very easy. It's still the same thing. If this is your B and this is your A, and I put here, all right, for example, and then you're going to have this. You will have, okay, so you know how parallelogram is, right? So you will have it this way. Sorry, I'm trying to make sure that okay. So this is 120 degree, and this is C, and this is D, and then this is your P equals to 8 Newton, and your Q equals to 6 Newton, and then the diagonal would be, yeah, be the resultant. All right, so so you're going to have here the angle of inclination of the resultant from the horizontal, the angle of inclination of the resultant from the horizontal vector. Okay, so that's how to represent the vectors using diagram. So we've been able to do this. In fact, if you can do this, oh wow, you've started. In fact, you've understood vector. You can answer so many questions in vector. If you can interpret questions into diagram, it will be very, very easy for you to undo those problems. So the next thing is we were asked to find the resultant of the resultant vector, right? The resultant vector of the two vectors. So let's see. I think I will need to apply the cosine rule. Yes, whenever you are dealing with vectors that are not parallel, vectors that are not perpendicular, you know that you are using, since they are not, well, once the vectors are not parallel and they are not perpendicular, you use cosine rule. But once one of the angle between them, or the angle between them, sorry, is 90 degrees, you know that they are perpendicular. So you use the Pythagoras theorem. So let's say I will do this using the cosine rule. You have that for number 2, you have r squared equals to p squared plus 2pq cos theta. Please, I will always advise you to do this. Put minus, yeah? Yes. Now, okay. Yeah, you need to put minus there. So you need to put minus there. And use the normal Pythagoras, the normal cosine rule. You use the normal cosine rule. Okay. So, all right. No. All right. So we have the angle to be, our P is equals to 8 Newton and our Q is 6 Newton and our theta is 120 degree. Right. We use the what we derive in physics. The formula we got in physics is plus, all right? So you are going to have r squared equals to 8 squared plus 6 squared plus 2p, that is 8 times 6, cos 120. All right. Okay, I can see. You can see. Okay. For us to use the minus, we will eventually cos 120. The reason I put the minus, I was supposed to use 60 degree because cos 120 equals to minus cos 60. All right, send it. Okay. So this will now become, this is 64 plus 36 minus 86. That is 48 times 2, 90. 90 what? Okay, let's see. This is 48 times 2, 96 cos 60. Okay. All right, so okay. So this will become 200 minus 96 times 0.5 because cos 60 is 0.5 and you will have 100 minus 48 and that will be equals to 52, right? So your r square equals 52. So you take square root of both sides and you have square root of 52. So with the help of your calculator, you use your calculator and you check for square root of, you press your calculator square root of 52. So what do you have? You have 7.2 7.271, right? 7.2, right, 1 Newton. Please, I'm using my calculator, all right? I use my calculator. So after that, the next thing we will do is to also find the direction. So there's so many ways about this stuff. So for this other shape, if we are using this other one, we have to extend it so that we can make it what? A right angle triangle. And what you see there is here would be 6 cos the theta here is 60, while here will not be because it's equivalent. This is minus, all right? Because cos what? Cos 120 is minus cos 60. So this place will be 6 cos what? Minus 6 cos 60, and here would be sine, will be 6 sine 60, right? So, but if you are using this other diagram, which is your parallelogram, if you extend it like this, you're going to have a right angle triangle here. Remember, this is your 6 Newton. This thing is still the same. So if you have your 6 Newton here, down here you're going to have minus, okay? So this is your 60 degree, right? 60 degree. So this will be, or let me say, okay? So opposite, if this is our x, opposite, and this is 60 over, so this will be sine 60 equals to x over 6. All right, still the same thing. 6 sine 60, and here will be 6 minus cos 60. So with that, we can now using alpha equals to tan inverse of the one that is not horizontal. Already in this question, it was stated that the 8 Newton is horizontal. So you have that. So you now have then we'll have this one is 6. Okay, our q is 6, so you have 6. Okay, let me put it this way: sine theta over p plus cos theta. So what we have as our theta here is 120, but it's equivalent to 60. So you have tan inverse of 6 sine 60 all over 8 minus 6, right? 6 cos 60. All right. Okay. Yeah. So the next we have here sine 60. Sine 60 is approximately 0.866. So that would be times 6. I think you use your calculator. You don't waste your time, you use your calculator. So you have here 6, right? 6 times 0.866 all over 8 minus, this one is 0.5, so you subtract, divide by 2, 6 divided by 2. That should say 6 times 0.5 would be 3, and 8 minus 3 is 5. So let me use my calculator. So what I will have here, okay, what I have here is 5.196 and then divide by 5. Okay, so I have tan inverse of this divide here, 1, here divide 0.3, yeah, 4 goes to 40, 0.8, right? Okay, so let me use my calculator also, and then okay, all right, so it's actually 9, yeah. Okay, so with the help of the calculator, you will now get the angle to be 46. The angle will now be 46.1 degree. All right, 46.1 degree. So what we have gotten so far is that the resultant vector, what is the resultant vector? 7.21 Newton. Okay. The resultant equals to 7.21 Newton inclined at 46.1 degree to the what? To the horizontal. All right, so that is how to solve this type of question. So when you come across this kind of question, it's very, very simple. All right, in the last part of scalar and vectors, we will consider the following learning content, and we have equilibrants and resolution of vectors, and the resultant of more than 2 vectors. Now, if we are to look at equilibrant, equilibrant from the word equal, it means equal. So if we are considering forces, we are talking about equal forces but in the opposite direction. So this is a single force which will balance all other forces, all other 3 forces or more forces acting together. It is always equals to, the magnitude is the same as the magnitude of the resultant of the forces, all right? Resultant forces. But it acts in the opposite direction to the resultant force. You consider 2 forces P and Q maybe representing in using parallelogram law. We can have 2 forces, yeah, maybe 2 forces P and Q. Okay, let me this away. And these 2 forces are represented using the parallelogram. So if we have a diagonal, the diagonal is going to be the resultant, all right, the vector addition, the resultant of P and Q. And then there is another force which will act in opposite direction to the what? To the resultant. And this other force is called the equilibriant force. All right. So if you actually know how to, if you can calculate, let's say you have gotten the resultant, your equilibriant in magnitude would be the same as, the magnitude would be the same, but in opposite direction. All right. The magnitude, let me say, the magnitude of the equilibrium force would be the same magnitude as the resultant, which would be the magnitude of this other organ. All right. So, but what happened is that the magnitude is equal to the resultant, but in opposite direction. Yes, it is in opposite direction. So whenever you calculate the resultant and you are asked to find a force that will balance, because this equilibrium force tend to balance these other three forces that are acting together at this point. If this is you look at this as a point, and then you notice that these two forces act at this point, and there is one force that can balance, that have the same effect as these two forces acting together, and that is a resultant. And this resultant, these other two forces acting all of them together at this point can be balanced with this other force. All right, can be balanced with just this one force. So this is everything about it. So everything about the equilibrium vector or forces, whatever you are dealing with. So the next one is I don't know whether we should, I have to bring up a question, okay? Let me just write down a question and see how we solve questions under the equilibrium. Let's solve one question. All right, I said we should solve one question under this equilibrium. So three forces F1, F2, and F3 are acting at point O, as shown below in the diagram. F1 with magnitude 10.0 Newton and F2 with a magnitude 5.0 Newton. Find the magnitude of F3. All right, when you look at this very well, in the diagram, you have that this vector, if you look at this F1, the direction of F1 is this way and F2. But the F3 you are asked is this other way. So it will be very easy to find the F3 if we can also find the resultant of these two vectors. You know that this can be represented in parallelogram. You see? Simple as that. All right. So this becomes the resultant of the two vectors. Yeah, simple as that. So what you do is, if you can find the resultant, it means that you can get because the only difference is that this is just opposite in direction, but will be the same magnitude. So you have that r square using your cosine rule. You have r square equals to 10 square plus 5 square plus 2 times 10 times 5 cos 60, right? So you have your 100 plus 25 plus right? Yeah, cos 60. And you have 125 plus 50, right? Is that what you have? So you have 175. This would be square root of 175. Okay. So let me just use your calculator. So what do you get as square root of 175? Okay, with the help of calculator, you have 13.23. Approximately 13.23 Newton. And the only difference there is that they are in the opposite direction. So since your F3 will have the same magnitude, because this force here balance the three forces that are acting together. So your F3 equals to the resultant, then equals to 13.3 Newton. So I think that is the only problem we have to solve under equilibrium. You can try other questions from your text. All right, the next we are having is resolution of vectors. This is just like the reverse process of vectors addition. You know, when we combine vectors, we get a single vector, yeah, which will have the same effect in magnitude and direction as the combined vectors all acting together. So we can just use this single vector. We can also resolve these single vectors into component vectors. All right, we can resolve that vectors into into two vectors, and these two vectors are called the rectangular component of that resultant vector. So if you are given a resultant vectors R, maybe R, for example, we had a vector this other way was given to us, maybe let me say V, and then we are now asked to resolute these two vectors into components. Let me have it this way. Okay, let me put it this way. Vector V. Now we can resolve this vector into two components, and that is the vertical component and the horizontal component. And we must know the angle of inclination of the vector, all right, the particular vector we want to resolve into component. We must know the angle of inclination from the horizontal or even from the vertical, any one. All right, so this is the vertical component and this is the horizontal component. Now, we are using right? So we have in here is that for the vertical component, this is Vy, this is our vertical component, horizontal component. You have the sine theta equals to, right? Equals to, what do you have here? Vy over V, and that's to say the vertical component will be V sine theta. So we can call this one. So this is the vertical component of this vector. Then the horizontal component, cos theta cos the Vx adjacent over, so you're going to have Vx equals to V cos theta. And you have this as our horizontal component. All right. And also, what if the horizontal component is not given? Wow. Sorry, the angle of inclination from the horizontal is not given. I mean, angle of inclination from the horizontal is not given. So what will you do? Maybe they give the angle of inclination from the vertical. All right. So let's get some lesson here from what we discovered when we were doing elementary math. That should be SS1. You discover that sine of anything, all right, sine of anything equals to cos 90 minus what? That thing. All right. So if the angle is given from is, look at this, what you have here is from the vertical. So sine theta automatically equals to cos theta. So what happened here is this equals to 90 minus theta. So in that case, we can have the vertical component to be this cos the vertical inclination, that is the angle measured from the vertical, right? Angle of inclination from the vertical. So the same thing is applicable here. Your vertical component will not be, your horizontal component will not be V sine that angle that is measured from the vertical. Have you seen? It's just like opposite of each other, right? But you will see that this angle is that measured from the horizontal. So it's always advisable to make sure that it is measured from the horizontal so that you will not be confused. Yeah, You measure from the, and also it's very simple. Also, if you have, if you know that the angle is measured 30 degree from the 60 degree from the vertical, you know that already the horizontal will be 30 degree. Simple as that. So instead of you, if you will not like using this, you go for the 30 degree, right? So it's as simple as that. So that is how to resolute a single vector into its rectangular components. And these rectangular components are what? Perpendicular. These rectangular components are perpendicular. And if you know this vector, you can also have it that tan theta, the angle of inclination, equals to the vertical over the horizontal. All right. So this will be theta equals to the vertical component over the horizontal component. So that is how you get the angle of inclination. So this is all about vectors, resolution of vectors into its rectangular component. So let's try a question. Let's try one applied question. Let me just write down the question. Okay. Let's have this example. The example says two forces whose resultant is under Newton at right angles to each other. If one of them, makes an angle of 30 degrees with the resultant, determine its magnitude. I think this will need to have a diagram for it. It's very, very simple. So what we do here is we have this, and we have two vectors, two perpendicular vectors whose magnitude is 100 Newton, and this is the vertical component, and this is the horizontal component of the two vectors. What they are asking here is if any of these two vectors makes 30 degrees with the horizontal, with the resultant, what will be the magnitude? You can decide to put the 30 degree here. Maybe let's say it is the vertical that makes 30 degrees with the resultant. You will still have the answer. Or if you decide to say, okay, I want my the horizontal vector to make 30 degrees with the resultant, no problem, meaning that you are calculating this one. If you are putting the 30 for this one, you're calculating for this. So if it is the horizontal that is making 30 degrees with the, 30 degrees with this. So what we are going to do now, we will say the horizontal component is always equals to the vector cos theta, right? So we are going to have 100 cos 30, and cos 30 is 0.886. I think you use your calculator, so you get 86.6 Newton as the magnitude of that vector. Anyone, even if you put it here, it will still be the same answer. So this is one example. I think I will have to solve another example. Alright, let's consider another example so that you will get better. I think this time around it will be an applied example.